eat?
I want to eat burger.
So boring. Let's eat pizza.
No, I want burger.
No, pizza.
Burger.
Hey, stop. I have solution for you guys. I have coin. So this coin will decide what we want to eat today.
Okay.
So if head, we will eat pizza, and tail, we will eat burger.
Okay.
So head, we will eat pizza. Yay!
Okay lah, let's go lah.
Our group will present a simple coin toss experiment to show how probability works. Before we look at the results, this is the background of the study. Probability is basically about how likely an event is to happen. So, a coin toss is a great starting point because it only has two outcomes, heads or tails. Using this simple experiment, we can introduce key ideas like randomness, fairness, sample space, and empirical versus theoretical probability. When we toss a coin many times, we can compare the real frequencies with the theoretical probability of 0.5 for each outcome. But the result might not be exactly the same because chance and sample size can affect outcomes. In this experiment, we tossed coins, recorded the data, and analyzed the frequencies to see how closely they match the expected values.
Hi everyone, I will explain to you guys about objective for our project. For this project, we carry out a simple yet meaningful coin toss experiment. Through this activity, we aim to observe how work in real life and compare it with what mathematics predicts. Specifically, our objectives are to record all possible outcomes, calculate the probability of getting head or tails, and understand this difference between experimental and theoretical probability.
For this study, we focus on using a simple coin toss to understand basic probability. The significance of this study is that it helps students learn probability in a hands-on and practical way. By actual tossing coins, students get real experience collecting data and analyzing data instead of just reading theory. They can see for themselves how real outcomes sometimes differ from the theoretical values because of natural variability. This project also helps build analytical and critical thinking skills as students compare theory and real results. It also highlights why accuracy can be influenced by things like randomness and sample size. Overall, this study encourages students to appreciate statistics as a useful tool in real-life decision-making.
This experiment was conducted to observe the outcomes of a coin toss and to compare the experimental result with a theoretical probability. The sample for this study consisted of one standard coin, and the experiment was carried out by 3 groups members, each responsible for performing an equal number of tosses. In total, 30 coin tosses were conducted to obtain a sufficient sample size for analysis. In this project, we have 6 steps of experiment. First, a fair coin was selected as the main instrument for the experiment. 2. Each group member conducted a series of coin tosses, for example, 10 to 30 toss each other, in a consistent manner to reduce bias. 3. For every toss, the outcome at the head or tail was recorded in a table. 4. After completing all 30 tosses, the outcome will combine to form a full data set. 5. The frequency of head and tail was calculated and used to determine the experimental probability. The last step is the result were then compared with the theoretical probability, where both outcomes are expected to have a probability of 0.5.
Next is result and interpretation. From the data collected, we obtained 17 head and 13 tail. From this data, we can determine the experimental probability of head and tail. For experimental probability of head, the number of head will divide with total number of tosses, and we get 17 over 30. For tail, we use same method and we get 13 over 13. Next, we can compare our result with the theoretical probability. Since a pair of coin has only 2 possible outcomes, so the theoretical of getting head and tail are 1 over 2. After that, we can find the difference between the experimental and theoretical probability for head. So 17 over 30, we minus with 1 over 2 and we get 0.0667, which equivalent to 7%. This means head occurs 7% more often in our experiment compared to the theoretical probability. For tail, the difference is 13 over 30 minus with 1 over 2 and we get negative 0.0667, which equivalent to negative 7%. This shows that tail occurs 7% less than theory predict. In conclusion, our coin toss experiment achieved all our objectives. We conducted 30 tosses, recorded the outcome and calculated the experimental probability for both head and tail. Although the result was slightly different from the theoretical probability of 1 over 2, this small variation is normal because we only did a limited number of trials. If more tosses, the result would get closer to theoretical value. Overall, this project helped us to understand the difference between theoretical and real-life probability, and it showed us the importance of collecting data accurately and analyzing it properly.
Next, we have an example of continuous random variable with a given probability distribution. We were asked to find the value of m so that the total area under the curve equals 1, which is a requirement for any probability distribution. So, we split the integral into two parts, from 0 to 1 and from 1 to 2, and then integrated each piece. After evaluating the integrals and simplifying the expressions, we set the total equal to 1. From there, solving the equation gives us the final answer, which is m equal to 13 over 6. This ensures that the function is a valid probability density function.
Hi everyone, I'm back. I will explain to you guys question number 4. Number 2 is calculate variance. First of all, we have to know the formula. The formula is Vy equal to Ey square minus Ey bracket square. First, we have to find Ey. Ey equal to integrate 0 to 1 y square dy plus integrate 1 to 2 30 over 6 minus y dy. And we have to simplify and more until we get integrate 0 to 1 y3 square dy plus integrate 1 to 2 30 over 6 y minus y square dy. Now we have to integrate the question and you will get bracket y4 square over 4 0 to 1 plus 30 over 6 y square over 2 minus y3 square over 3 1 until 2. And you have to put the number out of the bracket into the y and you will get the final answer is 7 over 6. Okay, now we have make it fast. We have to find Ey square. Ey square equal to integrate 0 to 1 y square times y square dy plus integrate 1 to 2 y square times 13 over 6 minus y dy. And now you have to simplify until cannot simplify and you will get y5 square over 5 bracket 0 to 1 plus 30 over 6 y3 square over 3 minus y4 square over 4 bracket 1 until 2. And you have to put the number out of the bracket into the y and you will get the final answer is 271 over 118 for Ey square. Already get Ey square and bracket Ey square. So we have to put into the formula to find Vy. And Vy equal to 30 over 19. And now we can find variance 2y minus 1 equal to 2v4 minus v1 is equal to square bracket 30 over 90 minus 0 and you will get the final answer is 26 over 45. Bye!